In this tutorial video, you will learn how to form stainless steel sheet metal by hand with a few basic tools in order to make your very own Pulsejet engine. The video is lengthy, however it will save you countless hours of trial and error, which might otherwise end in failure. Also, considering the current prices of stainless steel, it might also save you some money as well. The plans for this specific engine, as well as others, can be downloaded for free at our site www.pulsejetengines.com.
Okay, in this video we're going to document building an engine completely from scratch. The engine we're going to be building is the Thermopulse 12. It's a Chinese style Pulsejet, and by Chinese style that means that essentially it's based off an engine that was produced by a model airplane company in China. And you can see that Chinese style has the intake facing backwards and then the long expanded tail. This particular design is one I came up with. The geometry is tweaked and tuned to perfection so that it can produce about 40% more power than the standard Chinese design. And we're going to be making it out of 20 gauge stainless steel. You can make it out of tubing if you don't have any sheet metal working tools or experience. Tubing is more expensive to buy though. Okay, so we have this sheet of stainless, and we're just going to be marking out the parts, measuring it with the square, so making sure everything's nice and straight. And we have a sheet metal cutter here. You can use a different kind of sheet metal cutter, like the nibblers or the ones that cut a little strip out. Any will work. We have these nice heavy-duty, long-sleeve welding gloves that I use for pretty much all fabrication because it gives you nice protection of your wrists and upper arms. And you have the hearing protection. And of course, I have my safety goggles on right now. These are some pieces we already cut out. This is for the tail section. You can see on the plans here. You just want to cut it to the length and then take the diameter and multiply it by pi so you get the length of the circumference. And then you have a rectangular sheet that you cut out for each part. So you have the tail, the center tube, and then the combustion chamber. Later we'll go into how to make the cone patterns and cut out the cone sections for the combustion chamber cone and the expansion cone. So they're already cut out. They need a little bit of prep work and straightening out before we roll them. And then we'll go on to the next step. Okay, there are a few ways you can make the cone patterns. For these cone sections here, there are programs available that you can download off the internet that will allow you to enter the dimensions, and then the program will output the file as a CAD drawing, and then you can print that up. But often these cone patterns are much bigger than a normal sheet of paper, and you would need a drafting size plotter to print them. So the Excel program that's included with the CD includes a cone pattern generator. Basically it will give you all the dimensions you need, and you have your cone pattern, and it gives you an angle, and then you draw a baseline and measure the angle and draw up from the angle, and then that will give you the angle between these 2 points. And then from that point where the angle is drawn from, it gives you an inner radius, and then you measure that inner radius and draw the curve, and it gives you an outer radius, and then you measure to that outer radius and draw the curve, and then you have a perfect cone pattern no matter how big it is, if it's 10 feet or 2 feet. It's much easier than trying to print them and patch them together out of multiple pieces of paper. And if you're just doing one piece, you can of course use that method to draw it directly on the stainless if you have a big sheet, or you can transfer it to cardboard or paper first. This is just an old pattern that I made up years ago that I still use. We laid that out and traced it on the stainless. And we have one for the small combustion chamber cone that we traced there. Like you might see all these lines all over the place where it looks like I've drawn twice, or there's other lines lining up. And that was just a matter of positioning things and tweaking them to maximize the amount of parts you get for a given space. Because if you just lay them out randomly, you'll wind up wasting a lot of material. Now, if you don't want to go through all the cutting out the parts and the cone sections, making it out of tubing does help a lot, but you still have to make the cone patterns. But also, in addition to the plans and the pre-made hobby engines, we also will sell kits for the hobby engines, as well as being able to custom make kits where we basically do whatever you want. We'll cut out the patterns to the size you need. We'll even roll them if you need them. And then you basically get the box full of semi-finished parts that you just need to do a little bit of work and weld them together, and then you have a finished engine that you can run. That greatly simplifies things for a lot of people because they either don't have sheet metal working equipment, or it's just a lot of learning curve to get into for them. Okay, so we have these marked out. We're going to cut them and move on to the other parts. I'm just going to cut these out and skip to the next section because it's incredibly loud and not particularly interesting. You just follow the line with the cutter, so it's kind of hard to mess up. Okay, so now we have the main parts of the engine cut out. Still need to cut out the combustion chamber cap and the parts for the intake, but we're going to be doing that later because we're going to be doing some of the modifications listed in the Advanced Builder's Guide for this particular engine. So we have the combustion chamber, the cone. This will be where the intake is connected to. You have the center tube, the tail expansion cone, and then the tail expansion here. Now you can see that after these are cut, they'll typically be bent at the corners a little bit. We're just going to take these on our aluminum table and hit them with a mallet to get those nice and flat and smooth. And then we'll go into the different methods of rolling them. There are a few ways you can roll them. Either use a slip roll. Slip roll works best for straight sections. If you're doing pulse jets most of the time, the slip rolls cannot properly handle the cone sections because the cone sections are too sharp and too big of a difference between the small section and the big section. But if you have one, you can try it out. But mostly I found that the best method is actually to do it by hand with several different size pieces of pipe and just brute force. It's very important to wear the heavy welding gloves because the sheet metal is extremely sharp, and especially if it's cold out, you can slice yourself open pretty good and not even feel it. The only way that you know that you got cut is that you realize that you feel warm blood running down your arm. Okay, so let's move on to the next step. Okay, so now we have the rectangular sections that will be formed into straight tubing, and we have it at the slip roll. If you have a slip roll, you obviously probably know how to use it, but for those of you who might be interested in buying one, there's a few things that you should know before you purchase one. First, this was originally one of those 3-in-1 machines that has a shear, a brake, and then the slip roll. No matter what brand you buy, they're all junk. The only thing that works on them is the slip roll itself. So I just took off the brake and the shear to make it a little bit easier to roll the slip roll, because all those parts move up and down and cause friction and aren't really needed when you don't use them because they don't work. You have the adjustments at the side and at the back to control the tightness of the rollers, and then that will give you a different size tubing. If you make it real tight, it will make small tubing. If you have it loose, it will just roll a nice, gentle, large piece of tube. To use it, you basically just stick the sheet in whatever way it needs to go, and you apply pressure here while turning this crank, and it just feeds it in and rolls it up. So yeah, if you're going to buy a slip roll, just get one that is only a slip roll, and that methodology works out with most machines, because all the ones that are like 3-in-1 or 2-in-1, they're just not as good as 3 separate machines that are specialized for the exact thing that you need to do. Also, I'll go into later with the cone sections and show you how to do it by hand. You can do the long tube sections by hand, but since I have a slip roll, I'm just going to use this and get them nice and straight. Okay, let's roll these up and move on to the next step. Okay, we got the straight tube sections rolled up. They only need a little bit of work to be prepped for welding, and they can be all welded up. First, we're going to roll these, and I'm going to show you how to roll the cone sections without using a slip roll. This cone you might be able to get away with rolling in a slip roll, but this one is definitely too sharp to be able to do it adequately. So the best way to do it is just put on your heavy gloves and get a piece of rod stock or heavy pipe and do it by hand. And I'll show you how to do that in a moment. Okay, here I've just set up a piece of steel bar on a stool. And the basic method you can use is to kind of sit on top of the bar and then hold the cone pattern in both hands, and just start on this side, press down with your right hand, and kind of slowly let it bend down as you apply force, and you just want to slowly feed it along nice and even while bending it, and then once you get to the end you can use like a rubber mallet to get the ends perfectly smooth. It does take a little bit of practice, but once you get the hang of it, you can actually do it much more accurately and much quicker than with a slip roll. And also, as an added benefit, you get really strong arms, but you have to be careful when you're shaking people's hands so you don't break them. Okay, set up a tripod and get a shot of this for you. Okay, so we got this set up. You just can sit on the stool to keep weight on the bar to keep it from rolling around. I mean, you could make a setup specifically for this, but this is just a quick and easy for you guys to do it. I'm going to start with the cone just overhanging the edge a little bit, and you're going to put your hand on it and press down and curl down under, and kind of use your body weight to push down and curl it under, and just kind of like slowly rotate it around like we described before. Okay, so also another technique, if it's like a big cone, so you can start in the middle and just use all your weight to pull it down and get it to start to bend, and then you work your way from there. But we'll start at this end for this project. I'm just going to curl down and slide it along. You can see it start to curl. It's not going to be perfect when you first start it, but after a few passes you can get it totally nice and smooth and evened out. And you just want to kind of follow the contours of the cone so that it stays nice and straight and even. With the larger projects like this, it doesn't take a terrible amount of force to actually do this. So, you don't need to be super strong or anything. With the smaller ones, to do it by hand, it does take a little bit more strength, but for the big ones, you're not really bending the metal all too much, and it's not very difficult. So I'm just going to continue around. Just keep on curling down as you work along. Now that we're nearing the end, it's getting a little difficult to do it from that angle, so we're just going to switch sides and start going the other way. Okay, so now we have the cone at this stage. You can see that the edges here are still kind of straight. You're probably not going to be able to get them to smooth out by hand, so what I do is just put it over the roller and tap it with the mallet and just slowly work that to shape. That's what I do now. You're just going to start at the point where it starts to curve and line that up on the top of the rail and just kind of and work from there so that you're curling it down instead of just hammering a flat spot into it. It really doesn't take too much force to do that. So we got that edge starting to curl nicely. We're just going to flip it over and do the other side now. Now that's set up, we can pop it off and just kind of tweak it to a little bit better shape by hand. I mean, with very little work so far, we've got it to pretty much the final shape. Got the edges nice and curled to the shape they need to be. Just need to do a little bit of tweaking in a few areas to get them to round out a little bit better. And most of this you can even do by hand by just squeezing it with your thumbs. Like that right there just straightened out that, or rather curled that flat spot out. And there's a little flat spot here and here. And we're just going to tweak that out. You want to put your finger at where the flat spot begins so that the force is concentrated between the 2 points, and then you can just curl it in nice and smooth. So I'm just going to squeeze in. And it's starting to round out nice. Got the other one. Just going to squeeze in a little bit, and that's rounded out. You don't have to go too terribly crazy when you're doing these because, as you can see, there's still like a flatted area where the two sections meet, and that's actually a good thing because if you have it rolled perfectly round, when you run the weld bead down the seam, it will actually cause the metal to warp out and form a point. So if you have it flat rather than round, that natural warping, which you can't really avoid, will actually pull it to round. And that's exactly what you want to go for. Okay, I just need to tweak the bottom section a little bit now. I'm just going to take off my gloves to get a little bit better grip. You definitely have to be careful with handling the sheet metal because it's very easy to cut yourself, especially if you're using thinner sheet metal. Okay, got that set a little bit better. And now I'm just going to pop this back on the tube, or the rod, straighten that out a little bit better with the mallet. Take a little bit of a better curl to it. Okay, that's much better. And that looks pretty good. Just straighten this out a little bit. And that's pretty much to the point where you can weld it now. I mean, for doing it by hand, that's a pretty nice outcome. And you'll see when it's fully welded, the shape will form a lot better. If you do have any imperfections after you weld it, it's really easy to tweak them out of it by either just using a mallet or shaping it with your hand, because they always remain somewhat pliable. It's a lot easier to get the defects out before you weld it. Okay, so we're done with that piece. We're going to move on to the long section. Okay, so now we're going to be rolling the tailpipe expansion cone by hand on the metal rod. And this is going to be a lot more difficult because there's a lot more material here. There's a longer length that we'll have to bend. So typically for something like this, I would hold it with both hands and just align at the center and then push down on my hands with my body weight to get it to bend. You might start at the top or the bottom and just work your way up. So start here and just kind of curl it gently. You want to curl it differently over the entire length because this radius has to be much bigger than this one. So it's going to be gentle here and fairly sharp at the bottom. So I'm just going to push hard at the bottom, medium in the middle, and just kind of gently at the top, and then rotate it around a little bit, just dividing this into equal slices, like you're splitting a piece of pizza into additional slices, so that all the lines will be forming a nice cone. Okay, and just after 2 bends you can see it's already starting to take shape. It's overall still a very nice smooth curve once you get fully rounded, and you can tap out all the different spots with the mallet. It'll be totally smooth, and a lot of people ask how did I make that, because the people in the field that do sheet metal work realize that a lot of the stuff that I'm making you can't actually roll on a slip roll, and it comes out just as nice as if a machine made it, or it's like a factory made part. And you can do this method for the straight tubing as well. If you don't have a slip roll or don't want to spend $500 buying one, you still can do some very nice work and get very nice results. If you just put in a little bit of elbow grease. And once you get to an edge where you can actually grip it with your your palm and your thumb and reach under, it makes it easier to roll it around. You can use the rolling method like before, rather than trying to push down on it with both hands. You just want to support the backside with your other hand. Gently roll that down. And each time you do a section, you just want to move a little bit and get to the next stage and kind of blend everything together and get it nice and smooth. Now when we get to the edge, it's pretty hard to bend because you have to apply a tremendous amount of force over a very short distance. So I'm just going to use the mallet and get these curled in a little bit. Okay, that's just a very rudimentary curl to it. Come back to it and tweak it more later. And I'm going to start curling it in by hand on the other side. I'm just going to line up where it's supposed to go flat and just start curling in. Now for starting out, when you're doing this, it really helps if you have a bar that's the same diameter or close to the same diameter as the smallest part of the tube. And that way there's a lot less playroom, and it basically forces it to the right shape. But once you get the hang of things, you can do it by hand and go along smoothly and get it to come out perfect. Okay, so I'm just about to the point where I need a mallet to curl it in. Just get quick with the hand, get that finished up. Remember to keep the large part of the cone fairly gentle, and the bottom of the part fairly sharp. You can see here there's a little bit of a straight section that formed. Just by hand a little bit, and that's a lot better. So we have it mostly formed. The next stage, now that we got these edges curled, is actually fairly easy. Just basically put it between your hands and apply in pressure inward to basically crush it. And you just want to kind of roll the pressure from your fingertips down to your palms so that it forms a nice continuous curve without any pressure spots. And you don't have to go all the way in one step. You just want to slowly do that and work down the cone. And slowly it will pull inward and come to the right shape. Now, another way you can do it is actually to take a stool or kind of like a padded surface and use that and push down with your body weight if you're not strong enough to crush it in. Like this, something this size takes quite a bit of pressure. So we're just going to kind of set it on the bench like this, and then just kind of push down and kind of roll it as we're pushing down. And that will bend it inward. And we're going to do the same on the other end. Push it down, bends it in a little bit more, flip it over to the other side, push down, bend, push down, bend. And you can see that's pulled it in quite a bit. Okay, we can just tweak these spots a little bit more. Okay, now that we got all the parts rolled up, you can see that the engine is starting to take shape nicely. Just have them all lined up. The tail expansion, the expansion cone, the center pipe, the combustion chamber cone, and the combustion chamber itself. Now, some of the advanced features we're going to be adding to this engine is a special combustion chamber cap and a bullet-shaped dome. Will basically make it much more aerodynamic and able to cut through the air easily. This section is going to be basically standard. It's just going to have an intake that's going to start off standard, but we're going to have a very special aerodynamic intake flare shape that will basically allow the engine to generate ram air pressure even though the intake faces backwards, and the shape of the intake basically causes the air to stick to it, and it has a slow, gentle curve that goes back into the intake. And the air sticking to it essentially causes the air to reverse directions, go into the intake, and generate pressure when it's moving forward through the air. And this will give a nice little performance boost to the engine once it gets moving. Well, even statically, because the engine starts pulling air around it, so that air will also stick to it, and you'll get better pressure recovery from it. The center section, right about here, is the section that gets the hottest in the engine. I'm starting here at the cone, and right about there. Down past the intake gets a lot of cold air blown over it from the intake. So that's pretty cold. The combustion chamber is nice and big, but overall it's still fairly low temperature compared to the spot right here. So right in this area we're going to be putting a fuel vaporizer, and that will preheat the fuel. We're going to be setting it up for running on propane, and this will allow the propane to expand more than it normally would because we're putting heat into it. And it'll probably be a fuel vaporizer coil setup. We might do something special to get it to adhere to the engine and transfer heat better. But the injector is basically just going to come up into the intake and go to a very precise spot in the intake. And essentially the method that the fuel injector uses is a convergent divergent intake, much like a rocket nozzle. And in fact, it's going to be injecting the fuel into the engine at supersonic speed. So it can pull in additional air, and you get really great mixing because it just shoots into the engine so fast with so much force. And depending on the exact design of the injector, you can have it set up purely for pulling in as much air as possible, or set it up for extremely high mixing, or anywhere in between. So when you have that supersonic air shooting into the intake and say set up for mixing, it's going to cause a tremendous amount of turbulence and turbulent mixing, which will mean the fuel will burn extremely rapidly, and you'll get very efficient combustion and very complete combustion. And that's about all that's going to be done with this area of the engine. Later on, we might decide to add a water injection system somewhere in the line, but for now we're just going to stick with what I explained. And at the end of the engine, we're going to use a thrust augmenter. and this is just a specially shaped duct that generates more thrust by harnessing otherwise wasted energy from the exhaust. Basically, the force of the air flowing through the augmenter duct generates forward thrust by acting like an annular wing, and it also creates more thrust by harnessing the exhaust heat to create more expansion and more thrust that way. And with a good augmenter, if you build it to exactly the right shape, you can get tremendous amounts of performance boost out of it. Even a fairly simple primitive augmenter can boost the performance by anywhere from 30 to 50% thrust increase. And if you do things right, you can get 80 or 90% thrust increase or more, depending on the size of the augmenter. But for this design, we want it to be basically a high-speed demonstrator engine. So we're going to keep the augmenter fairly small to cut drag down and keep the overall weight down and still provide a modest amount of performance boost out of it. Okay, well, I've worked up quite a bit of appetite doing all this work. I think I'm going to get some food and call it a day, and we'll pick up tomorrow.
Thanks for watching, and make sure to rate, subscribe, and check out our channel for lots more videos.